Hello everybody, welcome to my another video in which I try to explain physics as simply as possible but not simpler. Today another problem related to the relative motion and relative speed. The problem is inspired by the similar problem in Polish textbook. The name of the book is in the description below. And I already have some pictures, so I will tell you what the problem is, but the text is also below the video in the description. So a customer climbs an escalator in a shopping mall at a constant speed, and it takes him 10 seconds. So the escalator is moving with some speed w, and the customer is climbing with speed v relative to the escalator, okay? And it takes him 10 seconds. So that's the first situation. So the speed of the customer relative to the surroundings, to the floor, to the shops in this shopping mall would be v plus w, and the distance from the bottom to the top of the escalator is some distance s, we don't know, and it takes him time t1 10 seconds. Then when the escalator is stationary due to a failure, a customer moving at the same speed relative to the stairs as before climbs the escalator in 30 seconds. So now the escalator doesn't move and only the customer moves with speed v. So this is the same speed relative to the stairs, to the escalator, but now it's the only speed also relative to the surroundings. So his speed in the frame of reference related to the shopping mall is v, and he covers the same distance from bottom to top s, and now time is t2. Okay, and finally calculate the time in which the customer would climb this operating without failure escalator while standing on them. So in the third situation, only the escalator is moving with the same speed w as before, and the customer is maybe, tired, so he is standing and just moving because of the motion of the escalator itself. So now w is also the speed of the customer relative to the frame of reference connected with shopping mall. So speed is now w, distance is as before s, and time is t3, which we don't know. So that's the physics of the situation. That's the physical or kinematical description of the three situations. So we have three equations, and now it's maths to solve them to find t3. And look, we have only these two times, nothing more. So we have but we have VWS, so we have three equations and three unknowns. Okay, so let's do it, and let's do it in a smart way. So the smart way would be to see that here we have V equals something, so we can plug this in for V here. So I rewrite the first equation, and instead of v I have s over t2, then I have plus w equals s over t1. So I can calculate w from this, or I actually have w, so I can plug in this here. That's also possible. So then I have what? I have s over t2 plus W, so S over T3 equals S over T1. Now look, I have S everywhere, so S on the left hand side is a common factor, so it's like this, 1, 1. So I can divide both sides of the equation by S, and what I have, 1 over T2 plus 1 over T3 equals 1 over T1. And now this is the equation where the only unknown is T3. Here we are. So let's have T3 on one side and all other things on the other side. So let's move this fraction to the right hand side. So then 1 over T3 is 1 over T1 minus 1 over T2. Alright, so let's solve it. Let's plug in the numbers. I mean 1 over T3. So 1 over T1 is 1 over 10 minus 1 over 30. So that's, you know, tricky part with fractions. So you need common denominator. So it would be 30. So you multiply this, the bottom, by 3, so you also multiply top by 3, so it's 3 over 30 minus 1 over 30, so it's 2 over 30, and you can further simplify it, so 1 over T3 is 1 over 15, but that's not the solution, it's 1 over T3, and what you want is T3. So what you do, you just flip it to be upside down, because 1 over T3, 1 over 15, so T3 is just 15 seconds. So that's the time in which he will travel through this escalator when just standing on them. So you see that it looks reasonable because it's a little bit faster if he climbs at the same time. Yeah, so that's all about this. Please ask questions in comments if any, and I will show you one more problem related to relative motion where the velocities will be in different directions.